Alright guys, I'm back. We're going to record one more video today and we're going to do the next problem on page 4 of our packet. So I'm still on page 4 of the Unit 2 packet. What I want to talk about is a new type of problem with the exact same sample space to begin with, okay? So let's look at the sample space to start, the scenario. It still says a box contains 30 different spools of ribbon. It's the same box. 12 are pink, 7 are green, 6 are white, 5 are gold. So let's just record. We have 30 total. 12 are pink, 7 are green, 6 are white, and 5 are gold. So just like we had before, we're recording our information that we need. Except this time, let's read the scenario. Now, when we reach into the box, we select a spool of ribbon and we keep it. And then we reach in and we select a second spool. This is called without replacement. So, what is actually happening when I keep one of the spools of ribbon? What's actually happening is that we are reducing the sample space. And let's be really crystal clear. We are taking one spool of ribbon. So we're actually reducing the sample space by 1. Because we're going to take one thing and we're going to keep it. So let's take a look at the very first question. Are these events independent or dependent? So in example 11, we said the events were independent because the sample space was never changing. But now we are in a world where our sample space is changing. So these events are dependent. The sample space is altered on the first choice. Okay, so we need to be crystal clear that these are dependent because the sample space is not the same each time I reach my hand into the box. So what does that really mean for us? First, that means that we are going to reduce our denominators by 1 each time. Second, that means we have to be careful and look at our numerators carefully to see what we have to reduce by. Okay, so we want to read our first scenario and figure out what the two colors are and how this is impacting the dependent scenario. So first it says find the probability of selecting 1 pink and then 1 green spool. Sounds familiar, right guys? I'm super excited. I'm super boring. Okay. Oops. One thing we forgot to write down was the multiplication rule for dependent events. So let's remind ourselves at the bottom that P of A and B is actually now equal to P of A times P of B given A, right? A actually is going to impact event B. So let's actually write that out a little bit differently this time. First, the spool is pink, and then it is green. So for us, that would be pink first, and then green, given we took one that was pink. So when we set this up, the first thing I always do are my denominators. So let's begin with 30 again. But remember that the second time, these are dependent. So my second denominator is actually 29. Now let's look at the numerators. 12 spools are pink. And if I take a pink one and I keep it, that does not change the number of green spools. So there are still 7 green spools left. And when I do this multiplication, I'm going to go straight to the decimal. I got 0.0966 when I rounded that to 4 decimal places. So please practice multiplying that and see if you get the same answer as me. Let's try C. Now we're asking 1 white spool and then 1 gold. But remember, this is without replacement. So we want to have white and then gold. For us, that would be the probability it's white times the probability it's gold given it was white. So remember, denominators first. That's 30 and 29. Let's also take a look at our numerators. First, we have white. That's 6 spools. And then we think about whether or not the white impacted the number of golds. And it does not. So we still have 5 gold spools. When we do this multiplication and round to 4 decimal places, I got 0.0345. Let's keep on trucking. Letter D says, find the probability of selecting 2 green spools back to back. All right, so let's take a look at what this means. That means I'd want to get green and green again. So first I do the probability I get green, and then I'm going to multiply that by the probability I get green given I already had the color green. This means, again, I still start with 30 and 29 as my denominators, but now that I have the same color back to back, what I keep has a direct impact on my second numerator. When I first reach in the box, there are 7 green spools. Then I take one and I keep it. So when I reach back in, there are only 6 green spools left. So this answer is a big change. When we have 2 colors back to back, let's say the same color back to back reduces the denominator and the numerator by 1. Okay, so this was a very different scenario than B or C. We see both our numerator and our denominator decreasing here. All right, let's do our last problem, and then we'll be done doing probability videos for today, because I know probability can be tricky on video. So this one says, find the probability of selecting 1 pink and then 1 that is not pink. So remember, last time we said there were 18 spools that were not pink. This was in the previous video. Why do we know that? Because 12 are pink and there are 30 total. So the rest of them, or the remaining 18, are not pink. So let's set this up. This would be pink and not pink. So we would first take the probability it's pink and multiply by the probability it's not pink, given it was pink to start. So let me do my denominators first, 30 and 29. There are 12 pink spools. But if I take and keep one that is pink, that does not impact the number that are not pink. So there are still 18 spools that are either green or white or gold left inside the box. And when I multiply these two and round to 4 decimal places, I get 0.2483. Awesome job staying with me today, guys. Keep up all your hard work. You can do this. I will see you back in class on Wednesday.